So welcome to the course of Linear Algebra, Math 120, Linear Algebra with Differential Equations. So this course has two portions, Math 120, Linear Algebra, with Differential Equations. So this course has two portions. Obviously, the first is LA, which is Linear Algebra, and the other is Differential Equations. In the first part, we shall discuss mainly about linear equations. So it's basically algebra of linear equations. It's properly if we say it. Now, what is a linear equation? First, we should know it. The recommended books for this course has already been uploaded on LMS and resources tag. I hope you can find them. You have to log in into your LMS account and then go to the resources tab. There you can find the recommended books as well as lecture slides and lecture notes. I have already uploaded lecture slides as well as lecture notes on LMS in the resources tag. Also, the course outlines also have been uploaded on LMS as well. You can see the course outlines. I have mentioned my office hours in those course outlines and the course breakup as well, component breakouts, marks distribution, quizzes, n-1 policy. There will be n-1 policy for the quizzes only, but not for assignments. And assignments will have 15% weightage. Quizzes also have 15% weightage for this course. Midterm has 30% weightage, and the final has 40% weightage. Everything I have mentioned in the course outlines, you can download the course outlines from LMS and you can see there. If you have any other question regarding the course or the marks distribution, you can ask me. So let's start now about the linear algebra. Now, what is the linear algebra? I told you it's basically algebra of linear equations. We discuss how to solve linear equations mainly, and then some advanced topics related to the system of linear equations. Now, first of all, what is a linear equation? Formally, linear equation in two variables, for example, you must have seen already in your intermediate classes what is a linear equation. For example, an equation of the form, if we talk about the two variables, ax plus or by is equal to c. This is a linear equation in two unknowns or in two variables where x and y are basically unknown variables, and a, b, c are constants, or you can say real constants. Real constant means they are real numbers. Okay, now an example of this could be maybe 2x minus 3y is equal to 5. So this is a linear equation in two variables. We can have linear equation in three variables as well. For example, we can write 2x, maybe 7y plus 5z is equal to minus 1. So this is another example of linear equation in three variables. We can have linear equations in more variables as well. You can write, for example, here 3x1 minus 2x2 plus 7x3 plus maybe 5x4 is equal to 3. So this is a linear equation in 4 variables, x1, x2, x3, and x4. These are unknown variables, and the coefficients are constants. So linear equations are basically are of this form. And in general, we can write a linear equation in n variables. In general, a linear equation in n unknowns can be written in this form: a1 x1 plus a2 x2 plus so on plus a n x n is equal to some constant b. So this is the general linear equation in n unknowns, where x1, x2, so on, xn are unknown variables, n unknown variables, and the other things a1, a2, so on, an and b are basically real constants. So this is basically the general definition of linear equation in n unknowns. I hope you get it. If you have any question, you can ask me. Let me add the people still trying to join in the meeting. So this is basically a general linear equation. You look at this equation carefully, that every variable has power 1 here. It's a linear power. Every unknown variable has power 1, or it has linear power. We say it. They are linear. Other than this, any equation would be called non-linear equation. Okay. For example, now examples of equations which are not linear. For example, if we have x, 2x plus 3xy is equal to maybe 4. So this equation is not a linear equation. Why it is not linear? Can anyone tell me? Anyone? Why this equation is not linear?
Because the variable power would be 2, 1 for x and 1 for y in the second term.
In the first term, we have x power 1, its power is linear. But in the second term, here we have x power 1, y power 1. So if we add them up, we get power 2 here. So this equation is not linear, because in each term, the unknown variable must have power 1. Whereas here in this equation, the second term, it involves product of unknown variables. So it is not linear. Another thing, maybe you can say minus x1 plus 2 square root of x2 is equal to 0. So this is again not linear equation. Okay, this is non-linear. You can say an equation which is not linear, you can call it non-linear. It is also non-linear because the second term involves x2, whose power is 1 by 2, not 1. Okay, so this is again not linear equation. Similarly, you can write many other things. For example, 2x1 plus 3x2, maybe minus x3 squared is equal to 0. This is again not linear, because here in the third term, you have power 2. So in each term, every unknown variable must have power 1. Okay, and the right hand side should be some constant. It can be 10, it can be 0, or anything. In the linear equation, if the right hand side, this b, If the right hand side B is 0, if this is 0, then we call this linear equation is a homogeneous linear equation. So remember this. I'm gonna write it here. I hope you can differentiate between now linear and non-linear equations. If you have any confusion, you can ask me. So in the definition of, if we call it 1, if we call this equation 1, then what is homogeneous linear equation? So if in equation 1 b is equal to 0, then equation 1 is called homogeneous linear equation. It is still linear, okay, but it is homogeneous. If b is not 0, then what do we call it? We call it non-homogeneous linear equation, okay? If b is not 0 in equation 1, then what do we call it? We call it, it is called non-homogeneous linear equation. Now, I hope you are clear about the basic and starting definition of linear equation. What is a linear equation? What is homogeneous linear equation, and what is non-homogeneous linear equation?
Sir,
Okay.
can you show the equation 1 again?
This one.
Right.
a1x1 plus a2x2 so on an xn is equal to some constant b.
Okay, sir. Thank you.
Okay. If this right hand side is 0, then we call it homogeneous. If right hand side is non-zero, not 0, then we call it non-homogeneous linear equation. Okay. Any other confusion? Any other question? So now in this course, we basically will discuss how to solve linear equations, particularly how to solve system of linear equations, not only a single equation. Now, system of linear equation is what? System of linear equations. Obviously, if we have more than one linear equations in some unknowns, then that will form a system of linear equation. For example, I can write here 2x minus 3y is equal to maybe 4, and another equation minus x plus 4y is equal to maybe 1. So now we have two linear equations which forms a system of linear equation. Okay, this is a system of linear equations, and with two unknowns. Okay, and two equations. Okay. So in this system, how many equations do we have? We have two equations. And how many unknowns do we have? Two unknowns. Okay. We call it a 2 by 2 linear system. 2 by 2 linear system means it has two equations and two unknowns. Okay. So we call it 2 by 2 linear system. It is basically order of the linear system. Okay, number of equations and number of unknowns. These two things, they determine the order of a linear system. Are there any question in chat window?
Sir, I have a question.
जी बेटा.
Sir, अगर for example जैसा इधर there is 2x and there is y as well, तो ये दो basically दो unknowns हो गए. तो
जी जी.
अगर सिर्फ 2x होता मतलब y ना होता लेकिन equations different होती, तो तब would we have considered के दो unknowns हैं या तब एक ही unknown होता, because x की value could be different in both these equations.
For example, what do you say? If we have 2x is equal to 4.
3y हटा दें, 3y भी हटा दें, 4y भी हटा दें.
हाँ.
और
Then
इसकी जगह कुछ और x में और जैसा 2x plus 3x or something, सिर्फ x हो
that's
हमारे
3x.
पास.
हाँ.
लेकिन
Then
अब दो x's की in both equation, sorry, okay.
जी जी. Tell me.
हाँ, because in both equations x की value तो different हो सकती है ना, तो would we consider that two unknowns या वो एक unknown बन जाएगा अगर हम सिर्फ x use करें?
It's basically, it's not a linear equation. Okay. A linear equation is basically an equation whose graph is a straight line in 2D. Okay. You have some constant a, y, ax plus dy is equal to some c. So the graph of this linear equation is always a straight line in 2D. I hope you understand. If you
Okay, yes.
cancel out or if you eliminate the other variable, you cannot have a graph. You have a single point.
All right.
Okay,
Understood.
that won't be an equation. I hope you got it. So
Yes, I did. Thank you.
in order to have a equation system of linear equation, you must have at least two unknowns. If you have only one unknown, that won't be a linear equation. Okay? So you have a system of linear equations. So a system must contain at least two unknowns and more than one equation. Okay?
Yes, sir.
Okay, thank you very much. Now,
Sir,
if
I
we
have a
look at,
question.
जी बेटा बोले.
Apologies, sir. So what if we had a line that said x equals 4, but the y, the coefficient of y is always 0, so we'd have like a straight line. Would we call that a linear equation? Like, let's say there's a straight line, a straight vertical line at x equals 4. Would that be a linear equation?
Again, if you have x is equal to 4, okay, and what would you like to find in this thing? It will be an equation, it will be a line. But in a linear system, there are some unknowns, and we are trying to find the values of those unknowns, means the solution of that linear system. If you have this kind of equation, then it is not a linear system. It's just an information, x is equal to 4. It's a line where x is equal to 4, and it's a vertical line.
Yes, sir. Yes,
So
sir.
a
Thank you so
linear
much, sir.
system involves unknowns, and we are interested to solve those linear systems, and we need to find the values of unknowns. Okay, let me give you an example from the daily life problems, maybe that will help you to understand a bit more about the linear systems. Let me change it now. No, it should come here somewhere. There is some adjustment problem, and I hope you can see it now completely. For example, you go to the market and buy day one. You buy some banana, 2 banana at some certain rate. Rate is X. You don't know the rate. Plus you buy 3 apples at some certain rate, which is y, and the shopkeeper charge you maybe 25 rupees. Okay, this is your day one shopping. Okay. Now, day two, you go again to the same market and you buy 3 banana and some 4 apples, and the shopkeeper charge you, he asks you for maybe 32 rupees. Okay, this determines a linear system. Now, what we are interested in here, that later on when you come back to home and you want to know how much the shopkeeper charged me for bananas and how much he charged me for apples separately. Okay, you don't know the rate of banana and apple. Okay, but combined he charged you for 2 bananas and 3 apples. He charged you 25 rupees day one. Day two, he charged you for 3 banana and 4 apples. He charged you 32 rupees. Okay, now what you are interested herein, you want to calculate the amount the shopkeeper charge you for the bananas and apples separately on both days. Now, the solution of this linear system will be what? It will be the value of x and value of y. And what would be the value of y? He has charged you for the bananas, and the value of y would be the rupees he charged you for the apples. I hope you get it. Okay, so this kind of problem in daily life you can solve by using linear systems. You can solve this linear system in order to get the prices of apples and banana separately. You can have many other bigger linear systems. For example, if you buy 3 things, you can have 2 bananas, 3 apples, 5 chocolates, and he charged you some maybe 50 rupees. You can have another day 3 apples, 4 bananas, and 2 chocolates, and he might have charged you some other amount. So you can make this linear system bigger. You can add more things in it. I hope you get it now. What are linear systems and what we are interested to?
Sir, I have a question.
GG.
Sir, you said that number of unknowns and the number of equations determines the order of the equation, right?
GG.
So
Order of the
agar-
system.
Order of the system, sorry. So how would the order of the system change, for example, if we have 2 unknowns and 3 equations, or maybe 3 equations and 2 unknowns?
So it depends the number of equations and number of unknowns as well. Okay, देखिए आप यहाँ से आप you go day 3 as well. Day 3 पे you again go to the same market and buy bananas and apples, and he charge you another amount. So you would have 3 equations and 2 unknowns, and the order of that system would be what? 3 by 2. Okay. Now the order might change as well if you buy banana, apple, and chocolate. Banana, apple, and chocolate. In that case, you would have 2 equations and 3 unknowns. And the order of that system would be 2 by 3. Okay, so it depends on your practical application where you are applying these concepts. Okay, what is the order of that system? Okay, it depends on the problem you are trying to solve. Okay, you take some daily life problem, you try to model it into a linear system, and then you solve it. How to solve it? This is the problem. This is what we are going to discuss. Okay, and how to make a problem as well. We'll discuss some of the applications in the course as well. In what kind of situations we can apply these kind of concepts in daily life. Any other question? Okay. Now, this is basically a 2 by 2 system. Okay, it's a 2 by 2 linear system. We can have a 3 by 3 system as well. Similarly, maybe if we can extend it 3 by 3 or maybe 3 by 4 or 4 by 3 or any of any order. ठीक है, यहाँ पे आप क्या करें, यहाँ पे आप 3 chocolates या 4 chocolates ले लें. He would have charged you 55 rupees. 4 chocolates को आप Z कह दें at a certain rate. Second day आप maybe 3 chocolates ले लें, ठीक है, and he would have charged you maybe 68 rupees. ये आपके पास क्या बन जाएगा, ये 2 by 3 system बन जाएगा, 2 by 3 linear system. If you go another day, day 3, for shopping, you buy 1 banana, you don't buy any apples. This is also possible. You don't buy any apples, so you would have 0y. And you buy 8 chocolates, and he charged you for this maybe 75 rupees. So this is also possible, but you have 3 equations and 3 unknowns technically. The second unknown here, number of apples, is missing here. It means you didn't buy apples that day. So this is what, this is a 3 by 3 linear system.
So, but there is a problem in this system wherein the price on the third day of the apples is unknown, right? So it may have changed again, but since we did not purchase the apples, we do not
No,
know the price.
we didn't buy any apples. Okay, we can still find the price of apples on day 1 and day 2.
Right.
Okay.
Right.
So, but remember that the rate of apples per kg and rates of apple and banana per kg, the rates do not change on all days. Otherwise, this will be an ill-posed problem. It will have no solution. ये नहीं हो सकता कि पहले दिन आपको वो बनाना फॉर एग्जाम्पल 50 रुपीज पर केजी दे रहा है, दूसरे रोज आपको वही बनाना वो 60 रुपीज पर केजी दे रहा है. In that case, X would change. So, in all these 3 days, the rates of the items should be identical. Okay, this is the first condition. So this is how we can write linear systems. Now, let's go back to the 2 by 2 linear system. And one more thing which I want to tell you is that let's go back to a 2 by 2 linear system. Now, what we are interested in this linear system, we want to find the value of x, y, and z. Okay. For example, if we have, we wrote that linear system 2x minus 3y is equal to 4, and the other one is minus x plus 4y is equal to 1. So this is basically a linear system in 2 equations and 2 unknowns. What we are interested in now, we need to find the values of x and y. How we can find it? I hope you have already studied how to solve a linear system of 2 unknowns and 2 equations in your intermediate classes, A levels. We can solve them simultaneously. We can solve them by using substitution method. These couple of methods you must have studied in your A levels. I hope you would say yes. Is there anyone who cannot solve these simultaneous equations? Everyone can solve simultaneously these 2 equations? How do we solve them simultaneously? We make the coefficient of one variable identical. We multiply this equation by 2. We multiply this equation by 2. 2x plus 8y is equal to 2. Now we subtract these 2 equations. Okay. So if we subtract or add, if we add these 2 equations, what do we get? We get another equation which is 5y is equal to 6. So the value of y is what? 6 by 5. And by inserting value of y in any of these two equations, we can get the value of x. So if we put in equation in 2 maybe. So this is, if we call this equation 1, and if we call this equation 2, so we are going to put this in equation 2. So we get minus x plus 4 into 6 by 5 is equal to 1. So this is what we go here, we go there, and x is equal to 24 by 5 minus 1, which is 519 by 5. So this is the solution. Solution means your x, so your x and y is what? The value of x is 19 by 5, and the value of y is 6 by 5. Okay. So this will be the solution of these two linear equations. Okay. For example, if you solve this 2 by 2 linear system, this would be the price of your banana and this will be the price of your apples which you have bought. I hope you get it. Okay. Now, what do we mean by a solution of a linear system of two equations? Our main system is this one. Okay. What do we mean by a solution of system of two linear equations in two unknowns? Okay. Now, let me write again these equations, or let me take some. So let me write again these equation 2x minus 3y is equal to 4 and minus x plus 4y is equal to 1. Now, geometrically or graphically, what are they? What are these straight lines graphically? These are in fact straight lines. And if we choose the first one, how can we plot it on XY plane? Because there are two unknowns, so we can plot it on the XY plane. The easiest method to plot any straight line on XY plane is to find its x-intercept and y-intercept. Its x-intercept is what? You put y is equal to 0. X-intercept is that value where the line crosses x-axis. So where the line crosses x-axis, there we must have y is equal to 0. So if we put y is equal to 0 here, what would be the value of x? X will be 2. So we get 1.20. This is your x-intercept of this line. Now, what is the y-intercept of this line? Y-intercept, in order to calculate the y-intercept, we need to put x equal to 0. So if we put x equal to 0 here, what is the value of y? It is minus 4 by 3. So y is what? Negative 4 by 3. So we get 0 minus 4 by 3. This is your this is the y-intercept of this equation, linear equation of a line. Now, if we try to plot it here, 1, 2. So this is our first point, 2 is here. And the second point is 0 minus 4 by 3. If we take 1 here and 2 here, negative 1 and negative 2, it is 1, 2. And the second point is around 1.33, negative 1.33. So negative 1.33 might be somewhere here. So now we have 2 points on an XY plane, and we can draw a straight line by joining these 2 points. So this is the graph of this 2x minus 3y is equal to 4. Now, the other line, how we can plot it similarly, you just put x equal to 0, y की value क्या आ जाएगी? 1 by 4. If we put x equal to 0 here, in order to calculate the y-intercept, And if we put y is equal to 0, we get x is equal to -1. So we have 2 points here, 0, 1/4, 0 is here, if 1 is here somewhere, so 1/4 is somewhere here. So this is the first point, and the second point is x is -1 and y is 0. X is -1 and y is 0 is somewhere here. Okay. So now we can join these two points, and we can get another equation of the line. Okay. These are basically the graphs of these two straight lines. Now, what is the solution of these two equations? The solution is what? XY. It is 19/5 and 6/5. So it is approximately basically 3.3 5 3s are 15, 4, 5 8s are 40. And this one is 5 1s are and 5 2s are. So 3.8 and 1.2. 3.8 x and y is 1.2. यहाँ पे we plot it properly. Yes, I think यहाँ पे did I make some mistake here in finding x-intercept and y-intercept? Can you people see here? y0 put करेंगे तो x की वैल्यू क्या आ जाएगी 2 और x0 put करेंगे तो y की वैल्यू -4/3. So 0 -4/3. And the other one is x0 put करेंगे तो y की वैल्यू 1/4 और y0 put करेंगे तो x की वैल्यू -1. ठीक है, I think it's basically if we plot them properly, they would definitely at 1 2 3 3.4 here, 3.8 here, and y is 1.2 somewhere here. They will definitely meet up here. Okay, this will go from here and this will go from here. They will meet up here, these two straight lines. And this solution is basically this point, which is the point of intersection of these two straight lines. Okay, 6/5. So if we have this system of two linear equations, basically they are straight lines. If we plot them, their solution will be basically the point of intersection of these two straight lines. Now, what is basically the solution of two straight lines? Is the point of intersection of these two straight lines. Is there any other possibility of solution if we have two straight lines, two linear equations? About the solution. No. In fact, while solving a 2x2 linear system, we have three possibilities. Number one, we are talking about only 2x2 system, a linear system having two equations and two unknowns. Then there are three possibilities. We can get unique solution. Unique solution means where the two lines are intersecting at a single point. At a single point, okay, intersection at a single point. Okay, and that solution is called unique solution of that 2 by 2 system. The other one is we can have infinite many solutions. How can we have infinite many solutions if we have two equations, linear equations?
On top of each other?
So the lines would be on top of each other?
Yes.
Overlapping lines.
The first line is this, line 1, and the second line is again on the top of the first line. Then how many points are there which we can say that they are point of intersection of these two lines? How many points are there?
There are infinitely many solutions.
Infinitely many points of intersections, because the two lines are on the top of each other. Then there are, in fact, infinite many solutions. Technically, not infinite many, they would be uncountable, because there is a difference between infinite and uncountable. Anything which we can count and it doesn't have any end, then we can call it infinite thing, infinite numbers. But here we do not count the numbers. We cannot count the numbers. Do you know what point comes after this particular point? We don't know. So there are uncountable many solutions of that linear system. When does this situation arise? For example, we have x plus 2y is equal to 3 and 3x plus 6y is equal to 9. So now we have this linear system. If you look at this linear system closely, you can see that the second equation is just a multiple of the first equation. Second equation is just a multiple of 3 of the first equation. If we multiply this whole equation by 3, we get the second equation. It means these two equations are identical. Why? Because we can take common from 3 from the left hand side. 3 plus 2y is equal to, we can take common 3 from here side, from this right hand side, and 3 can be cancelled out with each other, and we get exactly the first equation. So if we have this kind of linear system in which the first equation or the second equation is multiple of the other equation, then the equations are technically on the top of each other, and we will have infinite many solutions. In this case, how to find the solution? In this case, let me change the orientation of the board. No. No, again, no. This one. Now you can see, I think, properly. Let me, what was I trying to do? Okay. Let me clean it here. Now, in this situation, if we have this kind of equation, which the other equation is 3, we cannot solve this linear system simultaneously. Can you solve it? Try to solve. If this is the linear system, can you solve this linear system simultaneously? Can you find the value of x and y?
No, sir.
Why?
Because multiplying the first equation will give the second equation, and adding or subtracting them will remove the variables, I think.
Will cancel out everything. We are unable to find the value of x and y for this linear system. Okay. Now in this situation, we only try to solve the single equation. Now, the single equation cannot be solved here because there are two unknowns and we have one equation. Okay. In order to find the value of two unknowns, we must have at least two equations. Okay. In this situation, what we do, we introduce parameters which we call free variables. Okay. In this situation, we involve free variables or parameters. We can say any of these two variables as a free variable or as a parameter. For example, I say let y is equal to some parameter t, and this t belongs to R. T is a parameter and it can have any value in real numbers. So people are still trying to join in. This is participants, no. No, I suppose that y is equal to t, where t is some free variable or parameter. I assume it. Where t belongs to R, t can have any value from R. Now, if we put it back into this equation, I can find the value of x as 2t is equal to 3. Now, x is what? Its value is 3 minus 2t. Okay? And the solution of this linear system can be written as x, y, where x, आप इसको vector notation में लिख लें, vector notation, I hope you know it. X, y is equal to, where the value of x is 3 minus 2t, and the value of y is t. Okay, so this is your solution. The value of x is 3 minus 2t, and the value of y is t. We can combine them and we can write them in the vector notation, x, y, 3 minus 2t, and t. So this is your solution where t belongs to R. So now you can see that how many solutions are there. If we choose a particular value of t, we say that we choose the value of t is equal to 1. Okay, then what would be the value of y? Value of y is 1, and what would be the value of x? It will be 3 minus 2, 1. So your solution is what? X, y, and your solution is 1, 1. Okay, and for a particular value of t. Now, how many values of t can be chosen here from real line? Infinite many. So we have infinite many solutions of this equation and ultimately of this linear system. This is how we define infinite many solutions of any linear system. And this is what? This is basically a parametric form of this straight line. Okay, parametric equations of this equation, linear equation. Okay. If you have any question, you can ask me. Now, we were talking about solution possibilities. The first solution is unique solution, in which we can solve the simultaneous equations and get the only one solution, which is, we call it unique solution. The second possibility is infinite many solutions. This is how we handle infinite many solutions. Now, the third possibility is no solution. That a linear system, it doesn't have any solution. What is this situation? In that case, I told you that the linear system is inconsistent, means it is ill-posed problem. We are unable to find its solution. Third, no solution. Okay, this is the third possibility. And an example of this third possibility is x plus 2y is equal to 3 and the second is 3x plus 6y is equal to maybe 11. Now, what if you try to solve this equation, this system simultaneously? What would happen? Try to solve it. Try to solve it and tell me what is happening here. G. Hanzala Ahmed raised hand. G. Hanzala, ask your question.
Well, variables will cancel out, but the right hand side would not be equal to left hand side.
Yes, yes. So what is happening here? If we multiply this equation by 3, इसको 3 से multiply करें, you get 3, you get 6 here, you get 9 here. And you try to subtract them, you get minus, minus, minus. You cancel out the left hand side, you get 0 here, but here you get minus 2. So there is some kind of contradictory statement here. Okay? It's not a normal situation here. 0 is equal to minus 2, which is not possible. Okay, which is a contradiction. We reach at a contradiction. Okay, because 0 is not equal to minus 2. In this situation, you say that the original linear system is imposed. Okay, and that original linear system does not have any solution in this situation.
सर अगर graphically इसको हम draw करेंगे तो basically two parallel lines आएंगी ना which are not equal, which do not intersect.
So
parallel lines
दोनों parallel lines आएंगी. Graphically, these two straight lines will show up two parallel lines. They will never intersect. If they do not intersect, then we cannot have the solution of these two straight lines. Yes, you are right. ठीक है? Unique solution में क्या होता है? The two lines intersect at a single point. Infinite many solutions में the lines intersect at infinite many points, means the lines are on the top of each other. And in the third situation, the straight lines are parallel. Okay? They do not have any solution. But technically, what I told you in an apple banana problem, what happened, the rate of banana on the first day will be different from the rate of banana on the second day. Okay? So we can say that that linear system is inconsistent linear system or ill-posed linear system. Now let me write the definition of consistent and inconsistent linear systems. Let me write here. Any linear system which has at least one solution is called a consistent linear system. Okay? Consistent linear systems. Okay? If a linear system has at least one solution means it can have one solution or it can have infinite many solutions. At least one solution, we call it a consistent linear system. Okay? Linear system. Otherwise, what we call it? Inconsistent. Inconsistent linear system. I hope you get it. If you have any question, you can ask me.
Yes, sir. I have a question.
जी बोले हैं.
सर हमने देखा था कि जो infinite solutions थे उसमें basically जो दो equations थी वो एक दूसरे वो मल्टीपल दूसरी इक्वेशन वो पहली वाली को मल्टीप्लाई कर दें किसी भी नंबर से. However, in
हाँ
the
जी.
third one we see कि जो left hand side है वो multiply हुई है लेकिन right hand side multiply नहीं हुई. So is that something that we can use to identify these equations जब हम देख रहे हो या जल्दी हमें कुछ करना हो?
Yes, but only in the 2 by 2 system or at maximum 3 by 3 system. Okay. But when you have a linear system of 10 by 10 equations, 100 by 100 equations, then you cannot see it.
Okay.
Would you
thank
be able to see it?
I don't think so.
Okay. Then we are talking about general linear systems. A linear system, uh, it has basically this topic, linear system. It has many applications. Okay. Even weather forecasting. In weather forecasting, you have to solve a linear system which can have millions of unknowns and billions of equations. So, okay. So in that kind of situation, you cannot judge it. But here, I'm giving you a basic concept of linear equations and how to manipulate them, how to solve them, how to see different possibilities for the linear systems. Okay. So these are the three possibilities for all the linear systems, whatever the order of that linear system is. Unique solution, infinite many solution, no solution. These are the three possibilities, solution possibilities for any particular linear system of any order. Okay. Now, if we look at a different perspective of the linear systems, let's discuss that perspective also before moving forward. Today, I'm going to basically give you the basic ideas and introductory concepts of linear algebra. Now, the linear system, let me write again from here from my notes so that I can easily write the solutions as well. This one, yes. Consider this one, 5x plus y is equal to 3. And the other one is 2x minus y is equal to 4. If we solve this linear system, the solution is basically x, y, and the values of x, y are 1 and minus 2, 1 and minus 2. So this is the solution of that linear system. I hope you know now what is the solution. It is basically the unique solution. It doesn't involve any parameter. So this must be unique solution of that linear system. And these two equations, they must intersect at a single point. We can write any linear system into a matrix form as well. Okay. For example, if we write this left-hand side, the coefficient of these unknowns in the form of a matrix, 5, 1. In the first row, the coefficient of x and the coefficient of y, which is 1. So 5, 1, we write them here. And in the second equation, x, y, 2 minus 1. So we are writing here 2 minus 1 in the form of a matrix, and into unknown vector, x, y is equal to the right-hand side vector, which is 3, 4. I hope you know how to write these linear systems into a matrix form. You must have studied in intermediate classes. If anybody has not already studied these concepts, he can ask me any question. सबने पढ़ा हुआ है, सबने ये लीनियर सिस्टम थोड़ा बहुत मैट्रिसेस का पढ़ा हुआ है ना? एवरीवन मैट्रिसेस का पता है सबको?
जी सर.
चलें, that's great. So this linear system can be written in the form of this matrix now. Okay? And if we call this as a matrix A and this as a vector X and this as a vector B, this one, then this linear system can be written as A times X is equal to B. Okay, I hope you know the different notations for vectors and matrices. We'll discuss the basic definitions of matrices as well after this topic of linear system. So we can write this linear system into this form, in this matrix form, where A is this matrix. Okay. We can also investigate by looking at this matrix whether the system has unique solution or not. If A is what? 5, 2, and then 1 minus 1. Okay. Now, if you look at this matrix and just a little, 1 second, this one. If you assume that this is a vector 5, 2, and this is a vector 1 and minus 1, okay, and you try to plot them here on xy plane, okay, so this vector is what? Xy, x is 5, y is 2. So for example, we have 5 here, x, and y is 2 here. So this will be a vector, this one. This is your 5, 2 vector. We assume that this is your u vector and this is what v vector. So this is your u vector. Now, if we try to plot this one, x1, y minus 1, x1 here and y minus 1, for example, here. So we have this vector here, v, which is what? 1 minus 1. Now, you can see that these two vectors are independent of each other. They do not depend on each other. Okay? These vectors are independent of each other. If we try to make a parallelogram using these two vectors, how can we make a parallelogram? This one here and this one here. This will be a parallelogram. Okay? Now, this parallelogram has an area. What will be the area of this parallelogram? It will be the determinant of this matrix A. If we try to solve, and I hope you know what is determinant of 2 by 2 matrix, how to find it? How to find the determinant of this matrix? Anybody can tell me?
So you'd multiply 5 times minus 1, and then you subtract 2 times 1, and the answer comes out to -7.
-7. So the area is never negative, so we get 7, which is the area of this parallelogram. What is this? This is basically a parallelogram.
Sir,
Yes.
could you just recap how to find the determinant? I just can't remember it off the top of my head.
It's basically, if you have a 2 by 2 matrix, then you have to multiply the main diagonal elements minus the off diagonal elements, the product of off diagonal elements. Okay. So the determinant is 5 times minus 1, 5 times minus 1, minus 2 times 1, minus 2 times 1. Okay. So it is -7, -2. It is -5, -2 is -7. So this is how we find the determinant of a 2 by 2 matrix. I hope you recall it now. If we have any matrix A, B, C, D, then its determinant is denoted either by this notation, or we can denote it by determinant of A, and it is what? It is AB minus BC. Okay, and in fact, if we say that these are two vectors in xy plane, and we try to plot them here on xy plane, and if we can make a parallelogram with these two vectors, then the determinant of that matrix A is what? It is the area of that parallelogram. Now, what if these two vectors in the second case, which we discussed there for infinite many solutions. Infinite many solutions में क्या था, हमने क्या डिस्कस किया था वहां पे कि आपके पास सेकेंड इक्वेशन जो है वो फर्स्ट इक्वेशन की क्या है, मल्टीपल है. यहाँ पे हमने नहीं, यहाँ पे नहीं, यहाँ पे देखिए this one. No, कहाँ गया वो? चलें दोबारा लिख लेते हैं. Let's write it again. Second, third case. मैंने second case. Please mute your mics. देखिए हमने एक क्वेश्चन लिखी थी x plus 2y is equal to 3 and 3x plus 6y is equal to 9. ठीक है. In this case, the coefficient matrix A is what? It is 1, 3, 2, 6. Okay. Now, if we assume that this is the u vector and this is a v vector, and we try to plot them on the xy plane, the first vector is x1, y3, x1, y, for example, 1, 2, and 3, 1, 2, and 3, x is 1. Now, x is 6, 1, 2, 3, 4, 5, 6, maybe here, and no, sorry, x is 2 and y is 6. X is 2 and y is 3, 4, 5, 6 here. Okay. So the first point is this one and the second point is this one. The first vector is this one and the second vector is basically is collinear with this vector, this one. I hope you know what is a collinear vector. In this case, you can see that both vectors are collinear. Can we make a parallelogram with these two collinear vectors? Can we make a parallelogram with these two collinear vectors? Anyone?
No, sir.
No, we cannot make a parallelogram. Because in order to make a parallelogram, these two vectors should be basically, they should be independent of each other. They should not be collinear vectors. Now, if we have these two independent vectors, then we can make a parallelogram with these two vectors. If you have two collinear vectors, how can we make a parallelogram? We cannot make a parallelogram. Okay? If there is no parallelogram, then what would be the area of this thing? What is this now? It's just a line. And line cannot have area. In this case, the determinant of this matrix must be 0. Now you check what is the determinant of this matrix. It is 1 times 6 minus 3 times 2. It is 0. Why? Because there is no area here. There is no parallelogram. In that case, the determinant must be 0 here. If the determinant is 0, then we cannot find the unique solution of this linear system. If the determinant of any linear system is 0, then we cannot find unique solution of the given linear system. Okay? Whereas यहाँ पे देखें, यहाँ पे हमारे पास ये जो कोफिशिएंट मैट्रिक्स था यहाँ पे, इसका determinant 0 नहीं है. Its determinant is different from 0. Then there is a parallelogram and it has an area. In that case, we can find the unique solution of this system, which is the solution of the system is what? 1 minus 2. I hope you get it. If you have any question, you can ask me.
So, determinant से exactly क्या पता लगता है?
Determinant से हमें ये पता चलता है कि अगर determinant 0 नहीं है, तो unique solution होगा. अगर determinant 0 है, then there are two possibilities. Either there exist infinite many solutions or there exists no solution.
सही.
ठीक है?
Sir, what about the opposite vectors? Can we have opposite vectors?
कौन से ऑपोजिट वेक्टर?
मतलब जैसे आपने कोलिनियर की एग्जांपल दी, वो दोनों
हाँ
एक ही डायरेक्शन में थे, तो
हाँ,
इफ
ऑपोजिट भी हो सकते हैं। यहाँ पे अगर आपके पास ऑपोजिट डायरेक्शन में है, the other one is you can say this is negative and this is negative again, ठीक है? और यहाँ पे भी आपके पास फिर नेगेटिव आना चाहिए सो दैट कि सारा सिस्टम जो है आइडेंटिकल हो। तो इन दैट केस द अदर basically this one would be, the other one would be collinear but in the opposite direction. लेकिन still in that case also we cannot make a parallelogram by using these two vectors, ठीक है? We'll get a straight line which doesn't have any area. I hope you get it. If you have any question, you can ask me. Any question? We can generalize these concepts into 3 dimension as well. If we have a matrix of if we have 3 by 3 system, we can have a matrix with 3 vectors of 3 components, okay? Then in 3D we can have a parallelopiped. यहाँ पे तो parallelogram बनती है ना, ठीक है? तो in 3D parallelopiped, okay, we'll have a 3D version of this parallelogram. 3D version, I hope you can imagine it. In that case, if the determinant is not 0, then the determinant is what? Determinant is volume of that parallelopiped, okay? If the determinant is 0, then what does it mean? At least 2 equations are basically on the top of each other. And we cannot get a parallelopiped in 3D, and there will be no volume. In that case, we might have a parallelogram in 2D, but even for 2D shapes, we cannot find the volume. In that case, the determinant will be 0. And the system might have infinite many solutions or no solutions. I hope you get it. I think time is over. If you have any question, you can ask me. We'll discuss further things
Sir?
in next lecture. जी बेटा
सर
बोले।
मुझे एक क्वेश्चन था, जो डिटर्मिनेंट होता है वो एरिया को रिप्रेजेंट करता है या वो रिप्रेजेंट करता है कि एरिया पॉसिबल है फाइंड करना?
डिटर्मिनेंट अगर आप बात करें 2 डायमेंशन में, ठीक है, in the context of vectors, then determinant is basically the area of parallelogram. I told you what is parallelogram, ठीक है? Area is what? Is determinant is basically area of a parallelogram, ठीक है? अगर parallelogram exist करती है, area exist करता है, then, ठीक है? और 3 डायमेंशन में अगर आपके पास A मैट्रिक्स है जिसमें 3 by 3 एंट्रीज हैं, तो उसमें जो डिटर्मिनेंट होगा A का, वो वॉल्यूम को रिप्रेजेंट करेगा पैरेललोपाइप्ड के, ठीक है? I shall explain the parallelopiped again in the next lecture. If you have any particular question, Hamza, you can ask me. ठीक है? पैरेललोग्राम को अगर हम एक्सटेंड करें 3 डायमेंशन में तो पैरेललोपाइप्ड बन जाती है, ठीक है? पैरेललोपाइप्ड का वॉल्यूम होगा, उसका एरिया नहीं होगा, ठीक है? वॉल्यूम क्या होगा फिर? डिटर्मिनेंट ऑफ दैट मैट्रिक्स A होगा, अगर वही उसका 3 by 3 मैट्रिक्स होगा आपके पास. I hope you get it. If you have any question, you can ask me.